On the next two questions here, we're looking at slope and we're looking at how to determine a point that's on a line. And there are a multitude of ways that you could solve this. And I'm kind of debating on how to show you how to do it because it is for your final. So this says the slope of a line passing through this point is this. Which ordered pair represents a point on this line? I'm going to show you how to do this graphically, because to me graphically is a lot simpler and it's something that you can more easily apply. But let's look at a few review things first. Okay, first of all, we have our general equation for slope-intercept form, which is y equals mx plus b. Okay, we know that m is the slope of your line, and we know b is the y-intercept. Okay, just to review. That's just a review. Let's review what slope means. Slope is the change in y over the change in x. It is, and we'll call this delta y over delta x, how y changes over how x changes. And if you want to look at this technically, we're going to look at the vertical change over the horizontal change. One of the biggest mistakes people make is they get these two guys mixed up. And I don't want you to get these two mixed up. So when we look at slope, we want to look at the up and down is on the top and the left and right is on the bottom. So let's look at the slope that we have and let's look at the point we have. Okay, we have this point A, negative 5, 7. So I'm going to come over negative 5, 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5, 6, 7, and that's A. That's my negative 5, 7 point. That's on my line. Okay, what else do I know about my line? I know that my line has a specific slope, and that slope is 2 over 3. So let's look at 2 over 3 against what the slope means. That means that, and these are positive, right? Since it's positive, that means it's positive 2 and positive 3. Positive 2 means I'm going to go up vertically. If it were a negative 2, I would go down vertically. Positive 3 means I'm going to go to the right horizontally. Negative 3 means I'm going to go to the left horizontally. They're both positive, so we're going up and to the right, up and to the right, up and to the right. So let's start at our point and let's make our slope staircase. Let's follow our slope. Up 2, because it's positive, over 3. So I'm going to go up 2, over 3. This goes a little off the graph, up 2, 1, 2, 3, over 3. So you kind of get the idea. And these are a few points that are actually on our line. So I'm going to extend my line out. And so that's where my line goes. Now, if let's say that you would have been given this point, and obviously you can't keep going on the graph. Did you know that positive over positive is the same as negative over negative? So if I'm making my little staircase, and by staircase I mean this. This is what the staircase is when you go do your slopes. You make a little staircase. You can flip it to go the other way. So instead of going up 2 and to the right 3, that's the same thing as going down 2 and to the left 3. So I could go down 2 and to the left 3, and that keeps me on the line. So positive positive is the same as negative negative. Okay? So now let's look at the answer choices. We're trying to pick a point that is actually on this line. So which one of these points looks like it's on our line now that you've graphed it? Well, the first one is negative 4, positive 3. So let's look at that. 1, 2, 3, 4, up 3. Nope, that's not on our line. The next one is 2, comma 11. So over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's close, right? That's possible, so we can't really discount that yet. That's kind of going to be up in this area here, 211, maybe around in that area. 113, if I go over 1 and I go up 1, 2, 3, 4, whoops, 4, 5, 6, 7, 8, 9, 10, 12, 13, not even close. That's not on the line. And then we've got 0, 0. That's not on the line. So your answer is 211. That in fact is the point that is on your line. It's 211. So that's how you use the slope. So let's do the second example of this one. All right, so I'm going to give you another example. All right, in this particular example, the slope, again, let's rewrite that fun stuff out. Remember, the slope is equal to the change in y over the change in x. That's what that little triangle means, which means the vertical up and down change over the horizontal change. Okay, so if I'm looking at my slope is -1 over 4. Okay, the -1 over +4. The -1, since this is vertical, means I'm not going to be going up, I'm going to go down. That's a vertical drop. The +4 means I'm still going to go to the right. So let's graph our other point. We got that -5, 7 point starting again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So there's my D, which is at -5, 7. And let's go ahead and let's make our staircase with our slope. So my slope is -1/4. So I'm going to go down 1 over 4. Down 1, 1, 2, 3. Oops, sorry. Down 1, 1, 2, 3. To the right 4. Down 1, 1, 2, 3, 4. To the right 4. So you get the idea that this is what my line is going to look like, right? So let's kind of go ahead and just draw like our little dummy line through there. It doesn't have to be perfect, and you'll see why. Because most of these points, like we saw in the previous example, it's going to be self-explanatory. They're on the line or they're not on the line. So let's look at these two. Okay. So when I look at the answer choices, let's look at 5, 7. So if I go over 5, 1, 2, 3, 4, 5, and I go up 7, 1, 2, 3, 4, 5, 6, 7. Does that look like it's on my line? Nope. So let's go with B, -1, 4. So if I go over 1 and up 4, 1, 2, 3, 4, does that look like it's on my line? Nope. So let's go to the next one, 3, 5. Over 1, 2, 3, up 1, 2, 3, 4, 5. Boom. That looks like it's the correct answer, but let's make sure. 8, 2. If I go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 2, that is not on my line. Therefore, this is your answer. So that's how you do those questions where you're given a point and a slope, and you have to determine which of the points are actually on the line.